Have you ever wondered how electricity travels across vast distances? Imagine flicking a switch in your house and a complex dance of electrons ignites a bulb miles away. It might seem like magic, but the unsung hero behind this everyday marvel is a little device called a relay. Today, we're diving deep into the world of relay transfer, the unsung hero of long-distance electricity transmission. Buckle up, because we're about to unravel the science behind this fascinating technology that keeps our lights on, our devices powered, and our cities buzzing with life. But before we delve into the specifics of relay transfer, let's take a step back and understand the fundamental challenge of electricity transmission. Electricity, unlike water flowing through a pipe, can't be easily stored in large quantities. It needs to be generated and consumed almost simultaneously. This creates a logistical nightmare. How do we efficiently transport vast amounts of electricity over long distances, minimizing energy loss along the way? The answer lies in the concept of voltage. Imagine electricity as water flowing through a pipe. The wider the pipe, voltage, the more water, electricity, you can transport efficiently. Now, think of transmitting electricity over long distances like pushing water uphill. As the water travels, some energy is lost due to friction. Similarly, when transmitting electricity over long distances through power lines, we encounter resistance, leading to energy loss. This is where our hero, the relay, steps in. Relays are essentially electromagnetic switches. They can be as simple as a coil of wire wrapped around a piece of iron or more complex electronic devices. When a current passes through the coil, it creates a magnetic field that flips a switch, turning the circuit on or off. In the context of relay transfer, these relays are strategically placed along long-distance power lines. Here's how it works. Electricity is generated at a power plant at a relatively low voltage. This is because transmitting low voltage minimizes energy loss. However, low voltage also limits the amount of electricity that can be transported. Enter the first relay station. Here, the incoming low-voltage electricity passes through a transformer, which is essentially a device that uses the principle of electromagnetism to step up the voltage. Think of it like installing a wider pipe at the start of your journey. The higher voltage allows for more electricity to be transmitted efficiently over longer distances. Now, the high-voltage electricity travels through the power lines. But remember, distance is the enemy. As the electricity travels, some energy is lost due to resistance in the lines. This is where the next relay station comes in. At this station, the electricity passes through another transformer, but this time, it steps down the voltage. Imagine reaching the top of the hill and needing a narrower pipe to distribute the water efficiently to homes. The lower voltage allows for easier distribution to cities and towns. Finally, the electricity reaches distribution transformers near your home, which further step down the voltage to a level safe for powering your appliances. This process of stepping up the voltage for transmission and stepping it down for distribution is the essence of relay transfer. It's a delicate balancing act, transmitting enough electricity over long distances while minimizing energy loss. Relay transfer systems are incredibly complex. They involve sophisticated control systems that monitor voltage levels, automatically switching on or off additional transformers, or even rerouting electricity flow if a fault occurs on the line. This ensures a constant and reliable supply of electricity to homes and businesses. Of course, relay transfer isn't without its challenges. There are concerns about the environmental impact of power lines and the potential for cascading failures if a single relay station malfunctions. However, engineers are constantly working on improving relay transfer technology, making it more efficient and resilient. So, the next time you flick a switch and your lights come on, remember the silent hero, the relay transfer system. It's a testament to human ingenuity, a complex network that ensures a steady flow of electricity, powering our modern world. With that said, thanks for watching, and until next time.